we all share one common ancestor. Every single one of us watching right now can trace our lineage back to those early humans in Africa about 300,000 years ago. So then why do we look so different today? Where did the diversity of human appearance come from? Human evolution is a wild ride full of many twists and turns, and when it comes to the origin of human races, the answer isn't quite as simple as you might think. In fact, there's no real scientific basis for categorizing humans into races. The concept itself is a social construct that has changed over time rather than a biological reality. But still, the question remains, where do the physical differences among humans come from? So let's take a deep dive into the fascinating world of human evolution and find out, if all humans came from Africa, why do we look so different today? Well, it's all about that sun. Our skin color, one of the most obvious differences between human populations, is actually a result of evolutionary adaptation, primarily driven by the need to balance protection from ultraviolet UV radiation with the production of vitamin D, and here's why. All modern humans, Homo sapiens, trace their origins to Africa around 300,000 years ago, where our species evolved from previous hominins. But the story of skin color differences begins with these African roots and unfolds through migrations, environmental pressures, and genetic changes over tens of thousands of years. Our skin color is polygenic, influenced by 26 genes. Genes, those little things that determine your eye color or how attached earlobes are to the head. Just kidding, they also determine skin tone. But what are genes exactly? Genes are specific sequences of DNA, acting as instructions within the body's cells that guide the production of proteins, thereby determining traits and functions. Picture this: billions of years ago, Earth was a very different place. Our early ancestors, the hominins, were small, furry creatures who spent most of their time in the trees. Life was good, but as the Earth warmed and dried about 2 million years ago, forests receded, giving way to grassy plains. These areas, known as savannas, were full of new food and new dangers. It was a whole new world. Now, imagine a group of these hominins, perhaps a troop of early Homo erectus living in Africa around 1.8 million years ago. They looked a bit like chimps, hairy, hunched over, and spending their days searching for food. As the sun beat down on their pale skin, they scurried back to the safety of the trees at the first sign of the midday heat. This would have been a smart move, since it's well established that UV radiation increases exponentially between 10 a.m. and 4 p.m. But as time went on, these hominins began to change. Perhaps driven by the same evolutionary forces that continue to shape us today, they stood up straighter, walked further, and hunted larger prey. As they ventured further onto the open savannas, natural selection favored individuals with darker skin, providing protection from the sun's harmful rays. But wait, there's more. This melanin boost also gave them a bit of a bronze glow, making them look healthier and more attractive to potential mates. Fast forward a few million years and a new hominin emerges. Homo sapiens, our species, our ancestors. Picture a group of them about 300,000 years ago in Africa, our home continent. These early humans had darker skin, probably closer to what we'd consider black today, thanks to the increased melanin levels that offered protection against the intense UV radiation near the equator. Now, you may be wondering, how do we know all this? Well, scientists have studied fossils, ancient DNA, and the distribution of genetic traits across different populations. They've also examined the impact of UV radiation on skin pigmentation and the role of vitamin D synthesis. All of this has helped paint a clear picture of how skin color has evolved over time. Around 70 to 60,000 years ago, small groups of Homo sapiens began to migrate out of Africa into Eurasia. Now, when it comes to the migration patterns of early humans, it's important to remember that we're talking about very small groups of people, like a few dozen or a couple of hundred individuals. They weren't massive migrations like we see today, where millions of people move from one country to another. As these intrepid explorers ventured into new lands, they encountered environments with less UV radiation due to higher latitudes, cloudier skies, and seasonal changes. And here's where things get interesting. You see, the dark skin that had been advantageous in Africa was now a bit of a liability. Why? Because it blocked too much UV, which made it harder to synthesize vitamin D from sunlight. Vitamin D plays a crucial role in bone health and immune function, and its deficiency can lead to rickets, a condition characterized by soft and weak bones. So natural selection started to shift towards lighter skin tones, allowing more UV to penetrate and reach the vitamin D-producing cells. Remember those ancestral humans who ventured out of Africa? Their descendants would eventually give rise to the various populations found throughout Eurasia, each with their unique blend of ancestral African traits and adaptations to their new environments. Now, it wasn't just about where they lived. Mating preferences also played a role. For instance, in the Middle East, where people lived in a mix of arid, high UV and sheltered environments, intermediate olive to light brown tones evolved. This allowed for some UV protection while still enabling sufficient vitamin D production. It's important to note that this wasn't a clean division. There was a lot of interbreeding between different groups, including with archaic humans like the Neanderthals and Denisovans. In fact, non-African humans carry 1 to 4% of their DNA from these archaic relatives. When Homo sapiens migrated to new regions, they didn't just encounter different environments, they also interbred with existing human populations, contributing to the genetic mix. Imagine a group of early humans migrating to a new land and meeting another group that has already adapted to the environment. Over time, they would interbreed, sharing their genes and creating a new population with a mix of traits from both groups. This mixing of genes isn't just a matter of curiosity, it's a key part of understanding how populations evolve and adapt to their soil. In fact, genetic studies show that archaic humans like Neanderthals contributed 1 to 4% of the DNA found in present-day non-African populations. This means that somewhere along the line our ancestors had some company. Other human species like Neanderthals and Denisovans had been around for hundreds of thousands of years before Homo sapiens took the world stage. They were our distant cousins, each species evolving along its own path. And wouldn't you know it, when our ancestors met up with these archaic humans, sparks flew, literally. They started interbreeding, exchanging genes that added to the overall genetic diversity of future generations. Today, we can see evidence of this interbreeding in our own DNA. Non-African populations carry between 1 and 4% of their DNA from these archaic relatives, a tangible reminder of our shared history and the interconnectedness of all human life. Now, let's take a journey across the globe and explore how the migration of humans from Africa has given rise to different traits in various populations. Thousands of years ago, our ancestors, Homo sapiens, embarked on a journey out of Africa, carrying with them the legacy of their homeland. As they ventured into new territories, they adapted not only to different environments, but also to the genetic influences of the people they encountered. In Africa, ancestral traits are the most prevalent and diverse, reflecting the continent's role as the cradle of humanity. As humans migrated to other parts of the world, they carried with them the genetic legacy of their African roots, which has persisted through millennia. When humans migrated to the Middle East around 60,000 years ago, they encountered an environment with intermediate levels of UV radiation and limited plant and animal diversity. In response, they developed olive to light brown skin tones, which provided some protection from the sun's rays, while allowing for sufficient vitamin D synthesis. They also developed broader noses and fuller lips, which may have helped with humid air intake and cooling. As humans moved to South Asia around 45,000 years ago, they adapted to a monsoon climate with high humidity and heavy rainfall. In response, they developed broader noses, which may have facilitated the intake of humid air for cooling purposes. Meanwhile, in Europe, humans migrated around 45,000 years ago, adapting to colder, drier climates with less UV radiation. In response, they developed narrower noses, which may have helped conserve heat and moisture in the air. They also developed wavy or straight hair and lighter skin tones, which may have been advantageous for absorbing more UV radiation and synthesizing vitamin D. East Asians, who migrated to their current homelands around 35,000 years ago, adapted to a colder, drier climate with lower levels of UV radiation. As such, they developed a mutation in the EDA genes that resulted in straight, thick hair and more sweat glands, which may have been advantageous for thermoregulation in cold, dry conditions. They also developed epicanthic folds, which may have provided protection against cold winds or dust. Finally, in the Americas, humans arrived around 15,000 years ago and displayed a range of traits reflecting their diverse origins. Overall, these adaptations demonstrate the remarkable ability of humans to adapt to a wide range of environments, from the lush jungles of Africa to the frigid landscapes of Europe and beyond. So while the concept of race is a social construct lacking biological basis, the physical differences among human populations reflect the incredible journey of our species. From the sun-kissed savannas of Africa to the diverse landscapes of Eurasia, each step has left its mark on our DNA, shaping the beautiful mosaic of human diversity we see today. The differences in appearance among humans are the result of adaptations that occurred after leaving Africa. With African populations retaining the most ancestral and diverse traits, the concept of race is a social construct that emerged in the 17th and 18th centuries rather than a biological reality. In fact, genetic studies show that 85% of genetic variation exists within populations, not between them. As we conclude this exploration of human diversity, remember that our differences are not divisions. They are threads in the rich tapestry of human existence, each with its own beauty and importance. So let us celebrate this diversity, recognizing that we are all part of the same family, the human family. Thanks for watching, and I'll see you next time.